How many times have you missed a perfect DeFi trade because you were asleep or late to react? Sleeping face. In a world that demands instantaneous on-chain action, relying on manual execution is a losing game. The solution isn't just automation, it's verifiable, trustless automation. That's exactly what the Newton protocol is built for. What is Newton protocol? Newton is a decentralized infrastructure layer for verifiable on-chain automation, powered by AI agents. Think of it as the ultimate programmable financial assistant that executes complex, cross-chain tasks on your behalf, without ever needing your private keys. The core innovation is its combination of trusted execution environments, TEEs, and zero-knowledge proofs, ZKPs. This hybrid model allows off-chain computation, like running a sophisticated AI trading model, while ensuring that the execution adheres strictly to your rules, which is then cryptographically verified on-chain. Building your first agent workflow. Creating an automated workflow on Newton centers around agent models and automation intents. Step 1. Define the agent model. An agent model is the logic that defines what your agent does. Developers build these agents using the Newton SDK. For example, let's create a simple risk management agent. Its logic is, if a DeFi vault's collateralization ratio drops below 150%, automatically add more collateral to prevent liquidation. Your agent model will monitor an on-chain condition, the collateral ratio. Define the action, calling the vault's smart contract to deposit more collateral. Step 2. Set ZK permissions. This is where Newton protocol security shines. You don't hand over your keys, you create ZK permissions, which are granular, zero-knowledge circuits that encode the execution rules. Using the ZK permission SDK, you would define constraints for your agent, such as the maximum amount of collateral it can ever deposit, the specific asset, e.g., WETH, it is allowed to use, the exact contract address it is authorized to interact with. This cryptographically enforces that the agent cannot perform any action outside your predefined rules. Step 3. Submit the automation intent. Once your agent model is built and your ZK permissions are set, you submit an automation intent to the Newton network. This intent is essentially an order that says, network, find an operator to run my risk management agent according to my ZK permissions. The intent enters the automation marketplace, where operators, who run the agent code within secure TEEs, pick up the task. Step 4. Verifiable execution. When the on-chain condition is met, ratio drops below 150%. The operator's TEE executes the deposit transaction. The TEE generates a cryptographic attestation that the code ran securely. The agent also generates a ZK proof that verifies the transaction strictly followed the ZK permissions you defined. Both proofs are submitted to validators, who check them on-chain. If verified, the transaction is finalized on the blockchain, and the operator is paid in NEWT tokens. Why this matters? This isn't just basic if this then that automation. This architecture is designed for AI-driven strategies, cross-chain rebalancing, and complex institutional workflows, all with a layer of cryptographic accountability that DeFi has never had before.